Alright guys, here's a warm-up if you want to do it. It's up to you. I'm okay with you skipping the warm-up if you feel prepared for your test that's coming up on the 21st. The answer for the warm-up is right here. One of the answers is extraneous, one of them does work. It's up to you if you want to do this or not. We are going to start Unit 5. Unit 5 is not going to be on your test that you guys have next week, but since I gave you an extra day to review, we do have to start this unit. So the name of the unit is Rational Expressions and Functions. This is Unit 5, so we're halfway through the year. You don't need to worry about writing these down. That's not necessary, just so we know what we're going to be learning about. Feel free to pause the video whenever you want if you need time to write stuff down or anything like that. So the first topic that we have to talk about is variation. We're going to do 4 different kinds of variation throughout this lesson. So the name of this section is variation, and the first type of variation that we're going to talk about is called direct variation. So if you printed the notes for today, which I do recommend doing, there should be a spot for the definition on here. Again, like when we start a new unit every time, some of the stuff does seem weird at first. It will become more straightforward as we go through. So for direct variation, it says a direct variation situation is when 2 variables increase or decrease at the same rate. So the real life examples that I have for you is if you have an hourly wage, the amount of money you make varies directly with the amount of hours you work. So as you work more hours, you get paid more money. If you have an hourly wage and the amount of money you make varies directly. Oh, it's the same thing twice. Sorry, see that? You don't need that. The distance you are from a lightning strike varies directly with the amount of time before you hear thunder. So if you're closer to a lightning strike, then the amount of time will be lower. So since they're both, as you're closer, you're lower, they have a direct relationship together. The definition or the formula that you guys need to make sure you use for direct variation is y equals ax. A lot of times, and you'll probably see me do it today, instead of an A, we'll use a K. And this thing right here, that K or the A value, is called the constant of variation. So an example of this is, let's say that we have someone who is babysitting and they're making $10 an hour. Then the formula for how much money they make would be y equals 10x. Their constant of variation is 10. For every hour that they work, they get $10. When 2 quantities are related as y varies directly with x, it is called direct variation, and we use this equation. I said k is sometimes the constant of variation instead. And you'll see that this is linear because we know if we graph something like y equals 10x, that 10 is going to be the slope. Again, a or k, it's interchangeable. I'll probably use k more often. So if we look at some other real-life examples of this, as you travel more miles in a car, the amount of kilometers you drive also increases. The ratio between miles and kilometers would stay the same. That means that if you've driven 10 kilometers, you can convert that to miles, and if you've driven 20 kilometers, you can convert that to miles, and the ratio should be the same. Another example of, actually I'm going to show you one where there's no context first, just so we can see how these go. So it says, if y varies directly with x, and y equals 8 when x equals 20, find. The first thing we need to find is the constant of variation. I told you it can be a, or it could be k. So I want to write out that formula first that I said we always use for direct variation. As soon as you see it varies directly, we're going to write that y is equal to ax, or like I said before, you might see y equals kx. As soon as you see that direct, you want to think of this formula. It doesn't really matter what coefficient's up front, what that variable is. And in order to find the constant of variation, we're going to have to use the points that I give you. So I told you that, and y equals 8 when x equals 20. So we're going to plug in 8 for y. We're going to keep that k there because that's what we're trying to figure out, and then we're going to plug in 20 for x. You'll divide by 20 on both sides. You get k is equal to 8 over 20. You would never leave it like that, so you could divide by 4 in the top and the bottom, and you get 2/5. So your constant of variation is 2/5. So when I ask you for the equation of the variation, it's y equals, and then you take that k value and plug it back in. So y equals 2/5 x. And we could check our answer because we said if you plug in 8 for y and 20 for x, it should come to work out. And you'll see that here 2 times 20 is 40, divided by 5 gives me 8. So the equation for your variation is y equals 2/5 x. So again, we started with the formula, plugged in the x and y, figured out what our k was, and that gave us a whole equation. Okay, so I'm going to have you guys try this next one. It's going to be very similar. If y varies directly with x and y equals 2 when x equals 7, figure out the constant of variation and the equation. Give you a second to pause the video and then you can play it. So what I have is y equals kx. K is that constant of variation. I told you that y equals 2 when x equals 7. So we have that. We could divide by 7 on both sides, so you'll get k is equal to 2/7. So that's your constant of variation. But now when I ask you for the equation, we have to write out y equals 2/7 x. So now you know how this works. I'm going to give you some word problems so we can have some real life context to it. It says the length of a spring varies directly as force applied to it. When the spring is stretched 4 inches, the force is 8 pounds. So the length of the spring, let's call the length of the spring L. We're going to use a different variable besides x and y. The length of the spring varies directly as force, so we're going to call that F, is applied to it. So the length of the spring varies directly. We always have to put our k value first, or your a value. That's the constant of variation. So every time the length of the spring, that's L, varies directly with force applied to it, there's going to be our equation. We always put a k up front, and then we worry about our other variables. So the length of the spring is L, the force applied to it is F. It says when the spring is stretched 4 inches, so that's the length is 4 inches. So when L equals 4, the force is 8 pounds. So we're going to plug in 4 for L. We're going to plug in 8 for F. We'll divide by 8 on both sides, and you'll get 4/8, which is 1/2. So when I ask you to write the equation, this is your constant of variation. When I ask you to write the equation, it's going to be L is equal to 1/2 F. So the length of the spring is always half of the force applied to it. And that makes sense because when you applied 8 pounds of force, it stretched to 4 inches. So now I'm actually going to ask you a problem about this. It says, how far is the spring stretched when 12 pounds of force is applied? So if I'm telling you 12 pounds of force, that's going to be their F. So we're going to go to our equation, L equals 1/2 F. And we're going to plug in 12 for F. So it's going to be L equals 1/2 of 12. Half of 12 is 6. So then we get 6 inches as your answer. So make sure you get your equation, and then you're just plugging in your equation from there. Here is another one for you guys to try similar to this. This is our last example for direct variation. It says the cost C in cents of lighting a 100-watt light bulb varies directly as time in hours that the light is on. So that means that as the light bulb's on longer, then the cost of what you're paying to keep it lit up is going to be higher. The cost of using a light for 100 hours is 15 cents. Determine the equation for variation, and then determine the cost for lighting it for 2400 hours. So we're going to start with, we said the cost, we'll say that is C, in cents, varies directly with time. And we always have to put your constant of variation up front, your K. So now when we do this, we're going to look at the first numbers that they give us. They said the cost of using a light for 1,000 hours. So that's going to be my T. I keep the K here. Is 15 cents. So now when we solve for our constant of variation, our K, so we can make our formula, we're going to do 15 divided by 1,000. And if you want to, let's see, we can make that as 15 over 1,000. Fraction or decimal, we'll divide by, let's see, get my calculator out. Divide by 5, you get 3/200. So that's your constant of variation. If you get a decimal there, that's fine. Your equation here is 3 over 200. 3 over 200 t. And now we have our equation, so that takes care of this part, write the equation. And it says determine the cost of using the light for 2,400 hours. So we're going to take, to figure out the cost, we're going to plug in 2,400 for t. So we'll multiply 3 over 200, which again, if you got this as a decimal, it's 0.015. So your other equation could have been c equals 0.015 t if you would like. Times 2,400, and you'll get c is equal to 36. And then make sure you have your units here. Cost is c in cents, so this is 36 cents. So to light a light bulb for 2,400 hours, it costs 36 cents.